In this problem, we have the function h of x is equal to negative 2x squared plus 1 all divided by x minus 3. We want to find h prime of x, its derivative. Now notice we have a fraction here. Whenever you see a fraction, more often than not, that means you're going to be dealing with the quotient rule because there is division inside of your function that you're finding the derivative of. Sometimes you will be able to break the fraction apart and simplify it so it will just follow the power rule. But in this case, even if we broke this apart using the addition inside of the numerator, it would still leave us with two separate fractions, which would require the product rule. So, in this case, the quotient rule. So in this case, we are going to take this fraction and apply the quotient rule. Now the quotient rule has a very long, complicated formula, but there is a very neat trick that you can use. Now the trick is to remember the song that those dwarves sang, which is hi ho. So, using that method to just remember hi ho, hi first, ho second, we have a very odd thing that's kind of catchy to remember, and it's that your derivative, which in this case is h prime of x, is equal to ho d high minus high d ho all over ho ho. Now this might look complicated, and it is at first until you start committing it to memory, but this is just a method for how you can memorize a much more complicated formula. Ho means your denominator, like we said here. D high means the derivative of the numerator, because the numerator is high. Minus high is the numerator, times d ho is the derivative of the denominator, all over ho ho, the denominator times itself. So using this, we're going to start by listing off hi, ho, d high, d ho. And when we find them, we can just plug them into our formula and simplify. So we have high is negative 2x squared plus 1. Ho is x minus 3. D high, that's the derivative of negative 2x squared plus 1. So remember, we multiply the exponent out front. That gives us negative 2 times 2 is negative 4. Times x to the, and we subtract 1 from the exponent, so 2 minus 1 gives us x to the first, which is just x. So we get negative 4x plus the derivative of 1. The derivative of any constant is just 0. So plus 0, which we don't even have to write. Remember, if you're confused on this, just go back to the the power rule video, and it goes over that in more detail. Now d-ho says we want the derivative of x. So the derivative of x, or the derivative of any variable that's just by itself, is always the number that's in front of it, which in this case, there's technically a 1 in front of that x. So the derivative of x is just 1. And then the derivative of negative 3, well, negative 3 is just another constant, just like this 1 we had here. And we said its derivative was 0, which means the derivative of negative 3 is also 0. So the derivative of x minus 3 is all just 1. Now we can plug all of this into our formula. We have h prime of x is equal to ho d high. So ho we said is x minus 3. D high is negative 4x minus high d ho. High we said is negative 2x squared plus 1 d ho we said is just 1. And that's all over ho ho. So x minus 3 times x minus 3. And now it's just a matter of combining like terms, simplifying, and seeing if we can factor any common terms out. So we'll distribute this negative 4x first to get negative 4x squared plus 12x. And then we'll distribute this negative to get plus 2x squared minus 1. And this is all over x minus 3 times x minus 3. At this point, negative 4x squared plus 2x squared gives us negative 2x squared. Then we have a plus 12x and a minus 1. And this is all over x minus 3 times x minus 3. And at this point, we would just check to see if negative 2x squared plus 12x minus 1 would factor. It doesn't. You could do this with the middle out method or guess and check. Either way, once you end up multiplying this negative 2 and this negative 1 together, we can't find any combination that would add or subtract to give us this positive 12. So we know it doesn't factor. So we're left with h prime of x equals all of this. This is our derivative. And technically, we could just rewrite this as x minus 3 squared in the denominator to technically make it more simplified.